Hello all. In this video, we'll understand another program to check whether a given number is an Armstrong or not. So, an Armstrong number is 1. Armstrong number is 1. When you raise a number, when you raise the individual digits of a number to its order and summate each of these digits, you have to get the original number. For example, if I take 153, the order of the number is 3, that is number of digits in the entered number. If you raise each of the digits to the power of 3 and summate them, you have to get the original number. For example, for this it is 1 plus 125 plus 27, which comes out to be 153. So, 153 is an Armstrong number. Take one more example. If I take 1, 2, 3, 4, the order of the number here it is 4, that is number of digits in this number n. If I raise each of the digits to the order and summate it, I have to get the original number. So, this comes out to be 16 plus which is equal to 1. Hence, it is not an Armstrong number. This is not equal to the original number. Therefore, it is not an Armstrong number. Okay. Now, there are three components. One is finding order of the number. Second one is to find power, that is x to the power of y, and the third is to find whether a number is Armstrong. So, accordingly, this particular problem is solved using functions, and we are going to have three functions. One is finding order, the second one is the power function, and the third one is Armstrong, and the last one is the main, which is a driver function for all of these user defined functions. Okay. So, we will just have a look at each one of them. Okay. So, this is the power function, that is a function that calculates x to the power of y. Okay. So, let us take an example. Value of x is 5 and value of y is 3. I want to determine 5 to the power of 3, that is this function should return me the value 125. Okay. The function is designed using recursive calls. Now, what do you mean by a recursion? A function that calls itself with a different arguments is called as a recursive function. If you observe here, the function name is power. It accepts two arguments x and y. In this definition, in this function's definition, you again have a call for the same function, but with different parameters. That means, this is a recursive call for the function. The advantage of using recursion is its faster computation, okay, and also reducing the number of lines of codes. So, when you compare iteration and recursion, so recursion performs better in some situations. Now, let us check how this function returns the value of 5 to the power of 3. So, here x is equal to 5 and y is equal to 3. If y is equal to 0, y is equal to 3 here, it is return 1. So, this condition becomes false, we do not return. Y mod 2, that is 3 mod 2, check if it is equal to 0. This condition is also false because 3 mod 2 is equal to 1. This is not executed, so your system executes this. Now, what happens here? 5, x is 5 into, you alter the parameters, power of 5, y divided by 2, 3 divided by 2 is 1. This is the remainder, this is the quotient. 1 into power of x is again 5 comma 1. We have not yet completed the execution, this is again the call for the same function. So, once I come to this base condition, the values will be substituted and then the function returns. Okay, you are recalling this function with what parameters? 5 and 1. X is 5 and now y is 1. Y is equal to 0, the condition becomes false. 1 mod 2 is not equal to 0, it is equal to 1. So, again you call the same function. What do you do now? 5 into power of 5 comma 0 into power of 5 comma 0, that is 1 divided by 2, the answer is 0. Again this is the quotient and this is the remainder and this is the quotient. Now observe, we are again calling this function with different parameters. X is 5 now, y is 0. If y equal to 0, the condition becomes true and here you return 1. Here also you return 1. So, what is the complete answer for this? The complete answer for this is 5 into 1 which is equal to 5. This 5 will be substituted to its previous calls. What are its previous calls? It is 5 into 5 into 5 whose value is 125. You return here. Okay. So, the answer 125 is returned back to whichever function has called this. The next function is computing the order of the function. We will just have a look at it. Okay. Now, what do you mean by the order of the number? For example, if I had 153, here order is 3, that is the number of digits in a given number. So, x is the number that is entered by the user. Let me take it as 153. I will make use of a counter n which is initially assigned to 0. Now, while x, it means when x is greater than 0. Okay. Increment the value of n. Since x is 153, n is incremented by 1. N is incremented by 1. X is equal to x divided by 10. So, 153 divided by 10, the quotient is 15. So, this is reduced to 15. Go back and check the condition again. X greater than 0, 15 is greater than 0, it is true. Increment the value of n by 1, n becomes 2. X is equal to x divided by 10, the quotient is 1. Check the condition again, 1 is greater than 0, condition is true. Increment the value of n, n now becomes 3. X is equal to x divided by 10, 1 divided by 10, the quotient is 0. Okay. Now, check 0 greater than 0, condition becomes false. Okay. you come out and return the value of n. What is the value of n? It is 3. You return the order of the function. Right. So, we saw how to compute x to the power of y, we saw how to compute the order. Now, coming to the function that checks whether a number is an Armstrong number or not. We will just have a look at it. Okay. Now, the function name is Armstrong. It accepts one parameter, that is x, right. So, the first step that this function does is it calculates the order. So, we just saw if x entered as 153, the order function will return 3. So, what will be stored into n here in this particular function? N will be 3, right. Now, I have to compare the original number with a computed number, that is I have to compare this 153 with 1 cube plus 5 cube plus 3 cube. So, what I will do? I will store this original number into some other variable. So, here temp is equal to x, okay. Sum is equal to 0, okay, and one more variable temp is equal to 153. Right. Now, while temp, again value of x is a number, I mean some positive number, fine. While it is true, while true, so what happens here? 153 is not equal to 0. That is the meaning of loops, I mean that is the meaning of this test expression. So, while temp, it means until and unless this temp is not equal to 0. The same thing has been written as while temp, while it is true. So, what is remainder? This is one more variable that is used. R is equal to temp mod 10. So, temp is 153 mod 10, you have to take the remainder, that is 3, right. Sum is equal to sum plus power of r comma n. So, what will happen here? Sum is equal to sum plus 0 plus what are you going to pass to the power function? Power of r is 3. What is n? N is 3, 3 to the power of 3. So, this power function we just discussed, this will return 3 to the power of 3 value, that is 27. So, 0 plus 27 is 27, that will be stored in your sum 27. Temp is equal to temp divided by 10, which is equal to 15. The new value of temp is now 15, this is 15 now. Okay. So, this is our first iteration. Now, check for second iteration. Okay. Check for the second iteration. Now, what happens? Just understand, while temp, yes, it's not 0, 15 is not equal to 0, r is equal to temp mod 10. So, 15 mod 10 is 5, sum is equal to sum plus 27 plus power of what? R 5 comma n, n is 3. Okay. So, 5 cube will return 125 plus 27. So, what will be stored into sum now? 152. Okay. So, your new sum value is 152. Temp is equal to temp divided by 10, 15 divided by 10, the answer is 1. Okay. So, new value is 1, right. Now, the third iteration, I will just write it here. The third iteration, while temp, yes, 1 is not equal to 0 still, r is equal to temp mod 10. So, 1 mod 10 is 1. Next, sum is equal to sum plus 152 plus power of what? 1 comma 3. So, this will be 152 plus 1, which comes out to be 153. Temp is equal to temp divided by 10. So, 1 divided by 10, the answer is 0. Check the condition now. While temp 0 not equal to 0, condition becomes false. You come out of this while loop, you check the condition sum is equal to x. What is the value of sum? I have not updated it. So, here it is 153. Is sum is equal to x, condition becomes true, return 1. Okay. If it was not, you would have returned 0. Now, have a look at the main function. Okay. Have a look at the main function. Main, you call is Armstrong. See, in this particular program, I have declared the value of x as 153, but however, you can read the number from the user. So, is Armstrong. So, what are you doing here? You are passing x as a variable for this particular function. Is Armstrong of x, if it is equal to 1, if the return value of this is equal to 1, you print it is an Armstrong, otherwise you print it is not an Armstrong. So, in this case, this is going to return 153. Okay. Since you have passed x is equal to 153, this function is going to return 1. This function is going to return 1. So, you will have an output as it is an Armstrong number. Okay. So, if you enter 1253, this is not an Armstrong number. So, this will be returning 0. This condition becomes false. So, you will print it is not an Armstrong number. Right. Now, together how the function calls and all take place, we will just have a look at it. Okay. So, this is your main function. Okay. So, you have a call here is Armstrong of x. So, this will call this particular function is Armstrong. You are going to compute an order function. So, order is here. Okay. So, this is going to return a value, return n. Also, in the same function, you have a power function which is going to call this power. What is it going to return? It is going to return x to the power of y, which will be stored into your sum. Okay. So, this is your first call, this is your second call, this is your third call, and okay, these are the return value to your main from is Armstrong. Hope you understood the program. Thank you for watching.